Hello and good day, Algebra. We are moving on to POFitty-5 in our quadratic equation unit. And we just got fresh off of graphing parabolas, which some of the features of those parabolas that we were looking for were what? What are the three features of parabolas that we discussed and we used in PO54? Brent? The vertex, which is what? How is that significant when it comes to a parabola, Brent? It's the highest or the lowest point. Okay. When we start working with parabolas in context, we're going to care about the highest or the lowest point. You know, when you launch a rocket and the rocket gets launched, it goes up, it comes back down. We're going to care about how high the rocket got. Okay, that vertex point is going to come back later on. What's another feature that we cared about? Julia? The reflection point. And what does the reflection point do for us or give us when we plot it? Which gives it the parabola symmetry, right? That's how we kind of mirror it on the other side of the axis of symmetry is that reflection point. And then, of course, the other feature was the y-intercept, which is, we haven't talked about how we're going to use that yet, but it's where the parabola crosses the y-axis. That will come up again as well. So one feature of a parabola we have not talked about yet would be the x-intercepts. Okay, the x-intercepts. And one way to find the x-intercepts of a parabola is solving a quadratic equation, which you've actually done before as extra credit on your previous test. When you factored and then you had to solve for x, that was solving a quadratic equation. You didn't know it then, but you were calculating the parabola's x-intercepts. So solving a quadratic equation is finding the x-intercepts of a parabola. And really what we're doing here is what x, whoops, don't want two quotations, what value for x makes the equation equal 0. That's what you were doing as extra credit on your last test, and that's what we're going to talk about today. Finding the value for x, or the values, that makes the equation equal to 0. And those are the x-intercepts of your parabola. Okay? So finding the x-intercepts of a parabola, and the question we're asking ourselves is what x makes the equation equal to 0? And so there are essentially three different scenarios when it comes to a parabola having x-intercepts. The first is when a parabola would have two solutions, and it looks like this. Here's your coordinate plane. A two-solution parabola is going to cross the x-axis twice. Right? Either it goes down below the x-axis and comes back up, it crosses it twice, or if it's opening downward, it comes back up, or it goes up, comes back down, and it crosses the x-axis in two places. So you always have to be open to there being two solutions, okay? Two solutions for x. When would a parabola only cross the x-axis once? I mean, because if it goes down, it's got to come back up again. Or if it goes up, it's got to come back down. But when would it cross it only one time? Noah? Right. If the vertex is on the x-axis, okay, so either like this, right, where it only touches it once, or if it's opening down, like this, where it's only touching it once, okay, you only get one solution. And how about a parabola that would have no solutions? Josh? Okay, so when the vertex is not on the x-axis, and furthermore, because like in the ones up here, where the vertex is not on the x-axis, but it still hits it twice, for a parabola that opens up, if the vertex is above the x-axis, it curves back up before it reaches it. Or for a parabola that opens down, the vertex is below the x-axis. It curves before it reaches it. Okay? So 3 different scenarios of what could happen. You always need to be open to looking for 2 solutions, but understand that there might only be one solution, the vertex is on the x-axis, or no solution, it doesn't cross. Okay? Question so far? Okay. Let's look at some practice here. There are 3 types of a quadratic equation, or I should say 3 forms. The standard form, if you kind of want to put this up in the margin here, the standard form of a parabola is ax squared plus bx plus c. That's the one that we factored before. That's how all but one of your parabolas were written. It has an ax squared term, a bx, and a c term. One of your parabolas didn't have a c term, the very last one, right? So another form a parabola could take is ax squared term and a bx term, but no c term. What's the third form a parabola could take? Bridget? Ax squared plus c. It's got an x squared term and it's got a c term. And that's actually what we're going to start with here. Each of these has kind of a different method we can use to solve it, which is why this is a 2-part objective. It's a pretty large one. Well, we're going to start with the y equals ax squared plus c. There's no bx term, which means our b value is essentially 0 here. Okay? And the nice part about this one is that because there's only one x term, we can use the order of operations to solve it. That's why we're starting here. We don't have to factor, don't have to do anything fancy. We can just use straight up order of operations to solve this. Okay, so it says solve each quadratic equation. Check your answers by plugging them back into the equation. It says y equals 3x squared minus 75, but what number am I going to plug in for y here, given what we're trying to do? 0, right? So I'm going to rewrite this to be 0 equals 3x squared minus 75. Because we're looking for the x value that makes this equal to 0. And following the order of operations, what's my first step? Or following opposite operations, I should say, what's my first step? Noah? Sorry? So that's why I changed the way that I said that. If we knew what x was and we plugged x in here and wanted to find the value of this, I would square it first. But solving for x, we're using opposite operations. Where do I start, Noah? Adding 75, yeah. So add 75 to both sides, essentially cancel it out from the right, and we get positive 75 equals 3x squared. We've taken care of the addition and subtraction. What comes next? Julia? Divide by 3. Take care of any multiplication or division here. We're going to divide by that coefficient, cancel it out. 75 divided by 3 is 25, and that equals x squared. And this is why we're PERMDAS people, because the PEMDAS people look at this and they go all into a tizzy because they don't know what to do next, right? Addition, subtraction, opposites, multiplication, division, opposites, but E, what's the opposite of E? Equals MC squared. That's good. What is the opposite of an exponent since we are PERMDAS people, Brent? We're going to root both sides. Okay? I'm going to do this last step in red just so we can kind of, it's the new step here. We haven't really done this much before. And so the root of x squared being opposite operations, those are going to cancel out, and we're going to be just left with x here. Okay? The root of x squared equals x. And what is the root of 25? 5. But remember, we have to be open to 2 solutions here. So is there another solution to the root of 25, Elise? also negative 5. Why would that be, Elise? Right. The definition of a square root, right, what number times itself, in this case, equals 25. So we know that positive 5 times positive 5 equals 25, but so does negative 5 times negative 5. Okay? So you can either write both answers, or the mathematical symbol for positive and a negative is that. It's kind of like an underlined plus sign. That means positive and negative 5. And if you look back to my directions up here at the top, this arrow, it says your solutions will be opposites, right? Whenever you have an equation in ax squared plus c form, you're always going to end up with positive, negative something, in this case 5. Okay? Let's look at the next one. Y equals negative 5x squared plus 20. This one should go a little bit faster, and then we kind of got the process down. What's our first step here? Josh, subtract 20. Of course, we're going to make this a 0 first, right? So 0 equals negative 5x squared plus 20. So we got negative 20, oh my gosh, equals negative 5x squared, not plus 20, that 20's gone. Now what? What comes next? Someone new. We haven't heard from you yet today, perhaps. Heard from me. Lauren. Divide both sides by negative 5. It's a good thing our negative signs cancel out on the left here. Negative 20 divided by negative 5 is a positive 4. And that equals x squared. And then, Brent, root both sides. Again, I'll do that in red because it's kind of the new one here. And so our solutions for x are, Swicky, positive and negative 2. That's where this parabola crosses the x-axis. Soybean. On your calculator, take the root of a number. It should be like right above or kind of kitty corner to the 7. So here's your 7 key. Up to the left is your x squared key, but above that is the root symbol. Okay, and so to access the root symbol, you first need to push the second function key way in the top left, and then you'll press the x squared key, but because you pressed shift first, you'll get the root key, and then you'll type in the number you want to take the root of, and then you'll get it that way. Okay? Last one. Y equals 8x squared minus 72. Go ahead and take 20 seconds and work through this one yourself if you haven't already. Y equals 8x squared minus 72. Run through those opposite operations. Start by adding 72 to both sides. Then dividing by the coefficient 8. So you get 9 equals x squared. Take the root of 9, and you get positive and negative 3. Okay, and the directions do say to check your answer, and so all you would do, kind of like you plugged in the x value of the vertex when you found it. You'll take positive 3. You'll go back up here, and you'll say, okay, does 8 times 3 squared minus 72 equal 0? Well, 3 squared is 9. Times 8 is 72, minus 72 equals 0, right? So maybe. You should. Get in the habit of using parentheses. Just because when you check negative 3, if you put in 8 times negative 3 squared, you're not going to get the correct answer. You need to have that negative 3 in parentheses. And so it's just a good habit to get into. Use parentheses whether you need them or not. That way, when they don't matter, you're fine. And when they do matter, then you're still fine. Questions on this? Okay. Let's go to the next page. The second method we're going to talk about is y equals ax squared plus bx. So in this case, we've lost that constant. This was like that last parabola that you graphed in PO54 here. And we can't use opposite operations here because we have two x terms that can't be combined. Okay, we have that ax squared and the bx. Opposite operations are off the table. So instead, we're going to factor out the greatest common factor, which we've already kind of practiced with factoring back in PO50. It's the same idea. Okay, and the nice thing about this one is that one of our solutions is always going to be 0. You kind of get a freebie here. Okay. In this method, one of your x-intercepts will always be 0. Can anyone explain why that would be based on the form of this equation? Why one of your x-intercepts is always going to be 0? Noah? If you notice, back on PO54, the one you had to graph like this had an x-intercept of 0. Because what was the y-intercept of that parabola? 0, right? When there's no c term, it's like there's a plus 0 here. So what's the ordered pair of the y-intercept? 0, 0, which is also an x-intercept. So the reason why it works out that one will always be 0 is because a parabola like this will always pass through the origin because of what the y-intercept is, 0. Okay, so let's look at y equals 10x squared plus 30x. We have to factor out that greatest common factor. So put your brain back in PO50 mode. What's the greatest common factor of 10x and 30x? What are we, 10x squared and 30x? What are we factoring out, Quinn? 10x. We're also going to factor out the x term here. Okay. And when we say factor out, what we mean is if we're factoring out a 10x, we're going to take 10x squared and divide by 10x. What are we left with? Just x. Right? The 10s cancel out. One of the x's cancel out. We have one x left, and that's all we have left. When we factor out a 10x, we're taking 30x and dividing by 10x. What's 30x divided by 10x? What are we left with? 3. Okay. So we now have 10x times x plus 3 equals 0. And with our brain still back in PO50 mode, essentially we're looking for what value for x makes each of these expressions equal to 0. What value makes 10x equal to 0? What value for x makes 10x 0, right? That's where your 0 comes from. What value for x makes x plus 3 equal to 0? -3. And there are your solutions. Right? It helps to remember kind of what we did in PO50 because we have both the concept of factoring out the greatest common factor and kind of what makes that equal 0. We have some experience with that before. Both of those come back here. Let's look at the next one. Y equals, or 0 equals 6x squared minus 15x. What can we factor out of both 6x squared and -15x? Elise? 3x. What are we left with? We take 6x squared, divide by 3x. What are we left with? Soybe? 2x. Good. 6 divided by 3 is 2. X squared divided by x is x. We've got 2x. Then we go to our -15x, and factoring out 3x means we're dividing by 3x. What's -15x divided by 3x? -5. -15 divided by 3, -5, and the x's cancel out. So, again, what value for x, here's your freebie, what value for x makes 3x equal to 0? Anybody? 0. This one's a little more tricky, but we did have that shortcut that we talked about in PO50. What value for x makes 2x minus 5 equal to 0? Not just 5, because we have that coefficient to x there. Juliana? Positive 5 halves. Remember, two ways that we can answer this. The first way, kind of the mathematical way, if we're looking for a value for x that makes 2x minus 5 equals 0, set 2x minus 5 equal to 0, and solve for x. You'd start by adding 5 to both sides, then divide by 2, you get x equals 5 halves. Or the shortcut, the opposite of your constant, divided by your coefficient. Remember that? The opposite of a negative 5 is a positive 5. Divided by our coefficient 2, we get 5 halves. Noah? 2.5 would be fine. If your decimal terminates, then decimal values are fine. If you'd have to round it, then keep it in fraction form. Okay? The last one here. Y equals negative 14x squared plus 9x. What can we factor out of those two terms? Well, we can factor out something. Factor out an x. Yeah. There's no greatest common factor of our coefficients, so we're only going to factor out an x. So it's left inside of our parentheses now, negative 14x and positive 9. And because this equals 0, we're looking for the value for x that makes x equal 0. Again, this is your freebie. One of your solutions will always be 0. And then negative 14x plus 9, if we do it mathematically, we're going to set negative 14x plus 9 equal to 0. Because we want to figure out what value for x makes this 0. Subtract 9 from both sides. Negative 14x equals negative 9. Divide by negative 14 to get x by itself, and we get positive 9/14, which I don't think is a terminating decimal. So we'll want to keep it in fraction form. If we use the shortcut, the opposite of positive 9 is a negative 9. Divided by our coefficient negative 14, we would simplify that to a positive 9/14. So both ways get us the same solution. This parabola crosses the x-axis at 0 and 9/14. Those are the solutions. Soybean.
After the negative 14x plus 9 did you divide to get that?
First, I subtracted 9 to move it over to the other side. And then I divided by negative 14, which a negative divided by a negative is how I got positive 9/14 as an answer. Okay. Okay. Well, there you go. That's as far as we're going to get today. The third method you've already done is just factoring. So it's a review of PO49 and PO50. But we're going to save that. I don't want to overload you too much with this process here. But your homework for tomorrow. Anyone still need these notes, by the way, before okay? No? Your homework for tomorrow. Let's see here. What does this have in store for us? Go to POFitty-5 Part 2. And I would like you to do... boy here. You would say the first 3. Let's go with, from the first batch of 6, these are all that first form of ax squared plus c. Notice there's only one x term in all of them. So these first 6 are using opposite operations. Pick 3 of the 6 that you want to try. So 3 of the first 6, and then down below here where you see there's no c term, you have just the x squared and the x term. The next batch of 6, pick 3 of those. So 6 total, 3 from the first set of 6, 3 from the second set of 6, your choice. You do need to show your work. So turn off the microphone. Do need to show your work here. Okay? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms?
Congratulations, you did a really good.
Thank you very much. I enjoyed this. Is my favorite unit. I love this unit. It's just big brain math all over the place. I don't like teaching all of them. This one I do though. Okay? Still recording, so save your question. All right, that's how you math, folks.